Hello, everyone. Just a second. Okay, so today, nice relaxed session. I couldn't find anything better for you to do than just a Q&A today. So you can ask me questions about assignment 4. I'll be happy to answer. Probably won't give you solutions, but I will give you some guidance. Let's say. Yeah. So. Fire away. Any questions about assignment? If you're confused about a particular question, happy to answer all of your questions. Well, as much as I can without giving away solutions, but yes. Right. So please start. If you're stuck on a particular problem, let me know. We'll see what I can do for you. Go ahead. And we'll probably do just 1 hour today. Well, maybe more if we need. So the first maths, problem 9. Let's have a look. What is problem 9 on maths? I see. You have 2 vectors. Find the angle between 2 vectors. So what does it mean that vectors are perpendicular? So Zeno, can you? I hope I'm pronouncing your name correctly. What does it mean that 2 vectors are perpendicular? The dot product is yes. Do you know, Zena? Do you know what it means? They would cross. Well, yes, but mathematically, how? What's the simplest way of writing it down? Well, the rule is 2 vectors are perpendicular. Yes, the product. If A is perpendicular to B, this is the symbol for perpendicular, then A dot B is 0. So you have this vector and this vector are perpendicular. So let's say if A minus B is perpendicular to A plus B, then A minus B multiplied by A plus B is equal to 0. And you can simplify this as A times A minus AB plus AB minus BA minus BB equals 0. This cancels, and you're left with A times A. Well, A times A is modulus A, because the angle between them is 0. right? So it's a squared multiplied by cosine 0 degrees minus modulus b squared times cosine 0 degrees equals 0. So cosine 0 is 1. So a squared is equal to b squared. And that means a equals b. Modulus a equals modulus b. So if a and if a minus b and a plus b are the same, is perpendicular, if a minus b is perpendicular to a plus b, then these vectors have to be the same length. Okay, this is just an example. So you have a different example. And just a reminder, angle between vectors can be found as cosine theta is equal to a dot b, the dot product, divided by the product b. So you just multiply them, equate them to 0, and see where that takes you. Does that help? Zeno? Okay. So this is problem 9. Okay, it's not the solution for problem 9. This is some guidance on problem 9, of course. Problem Vishaka, is that maths? I'm assuming that that's maths. 13b. Okay. Which one did you find more challenging, physics or maths? That's a question. Which one did you find more challenging, physics or maths? Please answer in the chat. Everyone. Physics as usual. Physics. Okay, still physics. Okay, so heavy rope, is it match the well, if you've done when is it due? Is it just due on Sunday? This Sunday. If you manage to do this, the rest is going to be super easy for you. I just give you a hint. All you need to do is cut the rope in half. Imagine that you have 2 ropes. Two ropes. And then you can consider the forces on the left part and on the right part separately. So you draw this side and draw the forces. It's not. I don't think it is. I mean, it might be, but it would be a coincidence. Yeah, definitely would be a coincidence, because if you ooh, interesting. Yeah, that got me thinking. I don't think no, it's not. It's not the same as the ratio of tensions. Okay, physics for me. I've only done maths. The maths assignment is based on a physics assignment. That's what I meant, because the maths assignment you're doing, you can notice that there's a lot of physics in it. So it used to be a physics assignment. We've changed it slightly so that now it's a maths assignment. But you, if you are on the course, you are expected to do both. I hope everyone knows that. Okay, physics for me. I've only learned maths. Probably physics. Okay. What is it? Is the ratio as the same as the ratio between the tensions? It's related to, it's directly proportional to the ratio between the tensions, but it's slightly more complicated than that. So would you find the force and divide by G? Well, no. I mean, look, I mean, well, yes, effectively, if you say one force mg is equal to, I don't know, T1, and m2g is equal to T2. This is not the case, but you need m1 divided by m2. And of course, well, to do this, you can just divide them. Divide m1g divided by m2g, which is equal to m1 over m2, which is equal to T1 over T2. It's not the case, but this is approximately how you do it. So yeah, effectively, what you're saying is correct. You find the force, but divide by g. But it's you need to write down the equations and then write the force. Like, imagine you have a ball. On a, sorry, imagine you have a ball on a rope, and somebody's holding it. Somebody's holding the ball. So you have force of the holding, you have the tension in the rope, and you have mg. And you can split the tension into components. So you have t, if this angle is theta, so t cos theta, and this would be t sine theta. Then you could say that mg is equal to t sine theta, and F hold is equal to t cos theta. And then if you want to find m, you just, well, you express it from here. So it's not the force divided by, but it is the vertical component of the force in this particular case. Okay. Next question. So the hint here, imagine you have two ropes and then draw the forces on the two ropes. Next question. Physics or maths, assignment 4. Any questions valid? And find the force through the tension. Well, yes. You would force divided by and find the force through the tension. Both ends of two ropes. Yes, on both ends of two ropes. So you just look, if you take the left hand side of the rope, you can just say, well, it's the same as just having a point mass, right? So it's the same as, this is the left rope and this is the right rope. And then you draw the forces. There's a force like this, 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 there's a force like this. Hope that helps. So this is the left rope. This is the right rope. Next question. If you don't have any questions, that's going to be a very short session today. Has everyone done everything? Don't be shy. We are doing both physics and math. So I'm struggling a bit with the physics assignment. Anything in particular? Just need to I'll do the whole thing. Can you do more similar problems to problem 9 maths? Problem 9 maths. Hmm. Okay. Similar to problem 9 maths. So suppose you have A plus 2B is perpendicular to 3A minus 4B. Okay, so imagine they're perpendicular. If they're perpendicular, that means their dot product is 0. So you have A plus 2B multiplied by 3A minus 4B is equal to 0. Open the brackets, so get 4A squared. Now you can drop the vectors because A times A is modulus A times modulus A times cosine 0 degrees, which is modulus A squared, which is simply A squared, where A is the length of the vector. So when you multiply two vectors, two the same identical vectors, it's just their length squared. So 4A squared, where A is the length of vector A, minus 4AB plus 6BA minus so that's what 8B squared equals 0. So you have 4A squared plus 2AB minus 8B squared equals to 0. What can we do here? We can do 2AB is equal to 8B squared minus 4A squared. So A times B is equal to 4B squared minus 2A squared divided by 2. So I've rearranged divided by 2. Okay, and modulus A times modulus B Well, then cosine of the angle between them, theta, is equal to AB divided by modulus A modulus B. So that's going to be this, 4b squared minus 2a squared. And well, I mean, the numbers are different, and that's why it doesn't work. Numbers are different, and that's why it doesn't work here. But you just find an expression here, and then it should simplify. You just substitute modulus A. So modulus A, in this case, let me just check one thing. So problem 9, you say. Maths 04. So that's oh, there's two pairs of vectors. Ah, I see. I see. Then yeah, it makes perfect sense. Okay. There's two pairs of vectors, so you just work them simultaneously. What are we up to? Yeah, and you will have something beautifully canceling out. Yes. Okay. So you'll have a beautiful cancellation there. So, but I hope that makes sense. You find the angle by doing this, and this should give you the angle once you found the cosine. So it would be something beautiful, right? So, I don't know, something cosine theta would be, I don't know, cosine theta is equal to, let's say, square root of 2 over 2. And then that tells you that theta is equal to 45 degrees. 3a squared. Yes, 3a squared. I don't know why I put. But that's not the point. Okay, I hope you understand this. It's going to be 3a squared over 2, 3 over 2a squared. You substitute and you get something, and then you find the cosine. Okay, I can't go further with this. So you will have another expression like 3a squared, 3a minus 7b is perpendicular to a plus b. And then you do the same here. So 3a, and then you would have two expressions which look like this. And from there, you will be able to work out the rest. Hope that makes sense. Okay. Similar to problem 9. I haven't done the physics in 2 weeks and lost due to revision. Okay, similar to the rope questions. Question 7 maths. Question 7 maths. Okay. Problem 7 maths. Let's have a look. But then going between the diagonals. Look, if you have vector A and vector B, vector A and vector B, these are the sides of a parallelogram. If you want the diagonals of the parallelogram, there are two diagonals of the parallelogram. In the first diagonal, this one, this diagonal is A plus B. And we've done this last session. And the second diagonal of the parallelogram is this one. This is A minus B. So that's what you need to do. Okay. If A and B are the sides, A plus B and A minus B are diagonals. And the angle between two vectors can be found as cosine theta is equal to A times B divided by modulus A modulus B. So we are not finding the angle between V and W, right? We're not looking for this angle. We're not looking for this angle. We're looking for this angle. Yes, the angle between the diagonals. So please keep that in mind. Right. Do you want to see how to find the angle between any two vectors? Do you want to see how to find the angle between any two vectors? Just an example. Like a very simple one. Find angle between A, which is 3, 6, and B is 7, 2. Would you like to see how to do this? Or are you all confident that you can do this? What if they meant the angle is the bigger one? Both answers will suffice. Okay, any answer would. I think, yeah, when both answers are valid. Okay, so if you want to find the angle between two vectors, you remember the formula cosine theta, cosine of the angle between. Well, okay, first of all, where this formula comes from. Modulus A times B is equal to modulus A modulus B cosine of the angle between them. That's the definition. So from here, you can express cosine theta as A times B divided by modulus A modulus B. And AB is the product of the two, so it's 3 times 7, 3 multiplied by 7, plus 6 times 2, 6 multiplied by 2. So that's the dot product of the two vectors, divided by the modulus of the two vectors. The modulus of A is square root of 3 squared plus 6 squared, and the modulus of B is 7 squared plus 2 squared. And that gives you 21 plus 18, 21 plus 18, divided by 3 squared, 9 plus 36, that's 45, square root of 45. And this is 49 plus 4, this is 53. So this is going to be 39 over square root of 45 times 53. I'm not even attempting to calculate that, but I can find theta. Theta is the cosine, the inverse cosine of this monster. 39, 45 times 53. And square root our cos of 39 over square root 45 times 53. 37 degrees. 37 degrees, approximately, of course. All right, is that clear? Those who weren't clear about this, is it clear now? Elena or Winona, is that useful? Which part is confusing? Happy to comment on. To find the angle, cosine of the angle is the dot product. The dot product is just 3 times 7 and plus 6 times 2. And the modulus is square root of 3 squared plus 6 squared and 4 squared, 7 squared plus 6 squared. So you find the cosine. Once you found the cosine, you find the angle. The angle is the inverse cosine. Just try doing this by yourself and try drawing this with a vector as well, because 3, 6, this can easily be drawn. 3, 6. So that's 1, 2, 3, 1, 2, 3, 4, 5. Okay, that's too much. 1, 2, 3, 1, 2, 3, 1, 2, 3, and 7, 2. So that's 1, 2, 3, 7, 2. And it does seem like the angle between them is about 37 degrees. Quite reasonable. You can use square paper to do 1, 2, 3, 4, 5, 6, 7, 1, 2, 1, 2, 3, 1, 2, 3, 4, 5, 6. Right? 37 degrees. Okay. Any physics question would help. Any question, any physics question. Problem 8. So we've done problem 8 maths. Problem 12 maths. Problem 12 maths and problem 13 physics. Problem 12 maths. Okay, so problem 12 maths, you just need a good diagram. Oh yes, somebody asks about the rope. I will come back to the rope. Okay. The sides of a triangle. So you have a triangle, 15, 10, and 8. So 8, 10, 15. So BC is 15, BC is 15, AB is 8, 10, 15. Point M is chosen within the segment BC, such that BM to MC is 3 to 2. So we find point M, and the ratio of BM to MC is 3 to 2. Find the length of segment AM. Well, AM is a vector, and you just need to AM is a vector, and it's can be written as AB plus BM. AB plus BM. On the other hand, AM is AC plus CM. It doesn't help, does it? You still need Okay, AB, this one, and BM. You need to express AM in terms of AB and BC. So let's label them. Let's say AB is A and BC there's going to be AB plus that's 3/5 of BC. And this one is 3/5 of BC. I don't see it. I'm sorry. I didn't write this problem, and I don't see it at the moment. Just this brain stopped for a second. AB and BC. I mean, you can find it. You can find it using the cosine rule, of course. But I don't want to use the cosine rule. I want to use this method, which is given here. AM is AB plus 3/5 of BC. Okay, you can use cosine rule because you can find the angle. You can find the angle between the two vectors. I'm sorry, I don't see the intended method, but I can tell you that you can do this. Oh, can you? Oh yeah, you can do it using the cosine rule, but let me think about it. Let me think about it. Sorry about this. Cosine rule, you know the cosine rule, right? Cosine rule. Okay, so if this angle, if you have a triangle, 8, 10, and 15, and you want to find this angle, theta. So cosine theta is going to be 8 squared plus 15 squared minus 10 squared divided by 2 times 8 times 15. This is the cosine rule for a triangle. Then you find the angle, and then once you've found the angle, then you can use, because the fact you can use the fact that BM is 3 times 3, so 9, and this is 6. So you can use the cosine rule again. So AM will be, AM squared is AB squared plus BM squared minus 2AB BM cos theta. Okay. I've done way too many hints on here. Basically, here you go. Number 12 and problem 13 physics. Problem 13 physics. The duck is flying horizontally with speed u. A stone is thrown in the direction of the duck with initial velocity v0. Find the height of the duck if it is known that the stone hits the duck during the downwards part of the trajectory. Okay. So first of all, let's focus on the trajectory of the stone. Okay. And the duck hits, the duck is hit. So the duck is here when the stone is here. So if we draw a line like this, at an angle alpha, okay. This is H, this is H. So the duck travels from here to here, in the same time as the stone travels from here all the way to here. Okay, so this is H. This distance is H. So tan alpha is H divided by, let's call it L, divided by L. So L is equal to H divided by tan alpha. So L is H divided by tan alpha. So we found this distance is H divided by tan alpha. And the distance traveled by the horizontal distance traveled by the stone, horizontal distance traveled by the stone, and let's call it L1, and let's call it L2, is L1 plus L2, which is H divided by tan alpha plus L2. Horizontal distance traveled by the duck is L2. Okay. Is there a reasonable way we can find the, well, not really. Horizontal velocity of the duck is u. Horizontal velocity of the stone is v0 cos alpha. So v0 cos alpha multiplied by t is equal to h over tan alpha plus L2. And u multiplied by t, that's for the duck, so the stone and the duck. The horizontal velocity is u times t, and that's equal to L2. Well, we can sub that in. So v0 cos alpha multiplied by t is equal to h divided by tan alpha plus ut. So that's an equation. We don't know what to do with it yet, but let's count. What do we not know? We don't know h. We don't know t. So h is question mark. T is question mark. We can find the time to reach the maximum height. Ooh, interesting. Yes. We can find T1. The T1 is the time to reach the maximum height. And T2 is the time to reach this point. So time to reach maximum height, T1, is V sine alpha divided by G. Please try to prove it for yourself. And T2 is well, T2. You need the time to fall from here. Oh, mm, we need the maximum height as well. Okay. T. Yeah. You find the time. You need the full time. The full time T2 is second. Oh. The duck is traveling at Okay, well, we can find the horizontal. We can find the vertical velocity at h. At height h. At height h. Vertical velocity. I'm I'm just wary. I'm confusing. Yeah, I might be confusing you more than you need to. At height h, the vertical velocity. So we find it by using the formula v squared equals u squared plus 2as. And so v squared, that is the final velocity. So that's vy squared equals v squared sine alpha squared plus 2g. So that's well, minus 2g multiplied by h, 2gh. And from here, I can find vy is equal to square root of v squared sine squared alpha minus 2gh. That's the velocity. And the time from 0 to that velocity, so t2 is going to be square root of v squared sine squared alpha minus 2gh divided by g. Yes. So we found t1, we found t2, and we can sub that into here. And hopefully total time is t1 plus t2, and then you sub that into here to find h. And hopefully you get something beautiful out of it. Okay, sorry, I honestly didn't do this question because this question was added after me, after I've read and proofread this, and it just skipped my view. But well, give it a go. So yeah, just normal cosine rule. Yes, for that question. There was a question about the ropes. Let's do a different example on ropes, and hopefully that would make sense to you. Imagine you have a mass and it's suspended by 2 ropes to the ceiling. It's a 30 kilogram mass, and it's suspended to the ceiling, is attached to the ceiling by 2 ropes, and the angle is 60 degrees and 45 degrees. So we need to look at the mass. We draw the mass and we draw the forces acting on that mass. So there's a downwards force of the weight, which is equal to mg, which is 30 times 10, which is 300 newtons. 300 newtons of force. Then there's a force T1, T2 and T1. So this force is T1 and this force is T2. So this is rope 1, and rope 2. What we do is we split the tension into components. This is T1. We split it like this. And we split this like this. So if this angle is 60 degrees and this angle is 45 degrees, then this is going to be T2 cos 45, and this is T2 sine 45. This is T1 sine 60, and this is T1 cos 60. So we split the two. And once you've split them, you can kind of get rid of the force itself. So what you have now is you have the mass, and there are forces 1, 2, 3, 4, 5. So this is 300 newtons. This is mg. This is T2 cos 45, and cos 45 is square root of 2 over 2. T1 cos 60 is 1/2. T2 square root of 2 over 2. T1 square root of 3 over 2. And you can now write down that T1 times 1/2 is equal to T2 times square root of 2 over 2. That's the first thing. And second of all, you can write down T1 square root of 3 over 2 plus T2 square root 2 over 2 is equal to mg. And here you can express from here, T1 is equal to square root 2 T2. You can sub that into here. So square root 2 T2 plus times square root 3 over 2 square root 3 over 2 plus T2 square root 2 over 2 equals mg. T2 open bracket square root 6 over 2 plus square root 2 over 2 equals mg. So T2 is equal to 2 mg divided by square root 6 plus square root 2. So we found T2, and then we can find T1. So I'm sorry, I'm skipping a lot of algebra here, but hopefully when you look at it later on, you will be able to follow my steps if you've skipped them. And T1, sorry, is square root 2 T2. So is it? Yeah, square root 2 T2. So it's going to be 2 square root 2 mg divided by square root 6 plus square root 2. So that's how you do it. And with the rope, it's very, very, very similar. It's just when you have the rope, the first rope and the second rope, you look at the first rope. The first rope, there are 3 forces. One goes like this, one goes like this, and one goes like this. And for the second rope, you know what? I'm just going to draw it here. So the rope, so there's force like this, there's a force like this, and the gravity. There's a force like this, there's a force like this, and the gravitational force. Problem 13. Yes. Problem 13, the mass is the mass of the whole string. When yours cut the rope in half, it's going to be M1 and M2. So does that help? Does that help? Did these examples make more sense now? Okay. Okay. Well, let's finish here for today. I hope that was somewhat useful. And yeah, sorry for bit of a stuttered solutions for some of the questions. Otherwise, enjoy the rest of the week. Yeah, do your best and please submit the work by Sunday. And oh, you're welcome. See you again next week. Welcome. Bye.